Alright, so here's what we know about atoms so far. We know the mass of an individual atom, and so this is a relative mass or an average of the relative masses. So the mass number is equal to the number of protons plus the number of neutrons. Once again, if we think back to the last video, we saw that the size of an electron is so much smaller than the protons and neutrons. It doesn't really factor into the mass. 0.0005 AMUs, that means it's going to take hundreds, if not thousands of them to equal up to even a decent weight, so we don't even count them. So the mass, protons, and neutrons, and the atomic number gives us the number of protons, and if it's a neutral atom, then it's the protons and the neutrons, or electrons both. On your periodic table, it would look something more like this. So there's your mass number, here's your atomic number. So keep in mind the atomic number is what overall distinguishes a particular atom. Number of neutrons can change, number of electrons can change, but if the number of protons change, it becomes a completely different element. So for example, if this lost one of its protons and became 5, it would now be boron. It would no longer be carbon. Whereas if it lost one of its neutrons and have a mass of 11, it would still be carbon as long as it still had 6 protons. Okay, so the atomic number is what most of all distinguishes an atom. And if you follow the periodic table from left to right, you will see that the atomic number always increases by 1. That's the way it's laid out. The mass number increases by varying amounts, especially as you go farther down. In fact, sometimes it actually decreases as you go from left to right. Okay, so this is called the isotope notation. When we write it like this, you'll see elements written like this often. The mass number, which is called the A number. So watch out, sometimes they'll say carbon A equals 12. What they mean by A is that's the mass number. Why they chose A, I don't know. And the atomic number, which is the bottom one, that's the one that tells us the number of protons, is Z. And so sometimes you'll see an element with a Z equal to 6. So just know that A is mass number, Z is atomic number. It's something you need to remember. So then how many protons would this element have, this carbon? It would have 6 protons because we have a mass number or atomic number of 6. It would also have 6 electrons. How do I know it has 6 electrons? Because it's neutral. There's no charge up here in the corner. And that means that the positive has to equal the negative, so there's 6 and 6. And then how many neutrons does it have? So the mass is 12. And if we have 6 protons, then the other 6 have to come from the neutrons. Here's carbon again. So it's still carbon. It still has 6 protons, 6 electrons, but this time its mass is different. Its mass is different because it's slightly heavier, and it's slightly heavier because it has something more. Now, it can't have more protons. If it had more protons, it'd be a different element. So it actually has more neutrons instead. So if we have a mass of 14, we know there's 6 protons. That means there has to be 8 coming from something else, and that mass of 8 is coming from the neutrons. So that first one that we looked at, the one we looked at before, that would be carbon 12 because it has a mass of 12. This one would be carbon 14. They're going to have slightly different radioactive properties, so the way they decay, but overall it's going to be carbon. If you were to go and get a piece of coal is just pure carbon, there's going to be a mixture of carbon 12, carbon 14, carbon 16 in there. It's kind of fairly random. The numbers that are on the periodic table is kind of an average of all of the different isotopes of that particular element. And so an isotope then is elements that are the same name, so the same number of protons, but a different number of neutrons. And so all elements are going to have isotopes of one or another. And the different masses are caused by the neutrons only. Alright, here's another one. This is hydrogen. So hydrogen has, of course, 1 proton. Since it is neutral, we know that it also has 1 electron. And in this case, its mass is 1. And so then 1 plus what equals the mass of 1? And that would be 0. So that means standard hydrogen would have 0 neutrons. So no neutrons in it. Hydrogen's the smallest and lightest of all elements. It's composed of nothing but a proton and an electron. Unless, of course, it's this guy. So here is hydrogen 2, which has a mass of 2. That means it's going to have 1 proton, 1 electron still. And in this case, it does have 1 neutron. So this is what they call heavy hydrogen. Deuterium would be the scientific name for this molecule. If you've watched any kind of movie where they talk about fusion power, they always refer to deuterium, and that's what this guy is right here. It's a heavy version of hydrogen, which means it can fuse easily and create fusion power. Okay, so wrap it up, just talking about isotopes again real quick. So isotopes of an element have the same number of protons but different numbers of neutrons. Protons have to stay the same. So they exhibit identical chemical behaviors. So hydrogen 1 and hydrogen 2 will both bond with oxygen to form water. If you were to pull out a sample of water, you're going to find deuterium in there. You're going to find the regular hydrogen in there. Carbon 14 and carbon 12 will both bond with oxygen to form CO2. Both of those are found in relative abundance to each other in the environment.